Welcome dear students. Myself Dr. Ajay Semelty again with you from HNB Gadwal University. I welcome you all in our next part of transdermal drug delivery systems. We were discussing in our last lecture, in our series of lecture on novel delivery system, we discussed transdermal drug delivery system in our previous lecture. We discussed how the drug passes through the skin, what is percutaneous absorption, what is the mathematical modeling there, that modeling we discussed there, and we discussed the overall flow of drug across the skin. Then we discussed a little bit about the types of methods. Now we will be elaborating the preparation methods and the characterization in this lecture. Let's open up our discussion on the next part of transdermal drug delivery systems. After completing this lecture, you will be able to prepare the transdermal fields and you will be able to evaluate or characterize the transdermal drug delivery systems. We will be covering this lecture under the heads types of transdermal drug delivery systems, methods of preparation and its evaluation. As far as the types of Tdds we studied in our last lecture, just simple classification, if you say they are either they are reservoir system or the matrix system. What are the reservoir system? In which there is a core of drug from which the drug is being released, and in the matrix type the drug is dispersed across the polymer matrix. That's why it is called matrix system. Okay. However, there are the four major class of uh, transdermal drug delivery systems depending on their diffusion or the release characteristics, like membrane permeation control system first, adhesive dispersion type system, then matrix diffusion control system, and micro reservoir type or microsealed dissolution control system. Now let's discuss them one by one. First is membrane permeation control system. In this system, the drug reservoir is totally encapsulated in a shallow compartment, as you can see in this diagram. This is shallow compartment is here. Okay, it is molded from a drug impermeable metallic plastic laminate and rate controlling polymeric membrane. Okay, this is the rate controlling polymeric membrane, as you can see here. The drug reservoir is here in this which is backed with the impermeable backing, and this may be microporous or non-porous. It may be made of, and most of the time it is made of EVA copolymer. Drug is in reservoir, it is in solid particle or the suspension form here. Drug is here, as you can see here. Okay, can you see? The rate of drug release, from this type of transdermal drug release system can be tailored by varying the composition of polymer, permeability coefficient, thickness of the rate limiting membrane, and adhesive. Examples include nitroglycerin releasing transdermal systems, scopolamine releasing transdermal system, transdermal scop for 7 to 2 hours for prophylaxis of motion sickness, catapress, astrodome, nicodome. These are some of the examples. Now let me tell you what is the rate of drug release there. That dC upon dt is equal to Cr upon 1 by Pm plus 1 by Pa, where Cr is the drug concentration in reservoir. The Cr is the drug concentration in the reservoir. Pm and Pa permeability coefficient are they are of RCM and adhesive layer. While the Pm, a permeability of membrane, can be expressed by Kmr dm upon Hm, and in the same way Pa can be expressed by Kaim into dA upon Ha. What is Kmr and Km? These are the partition coefficient for the interfacial partitioning of drug from reservoir to the membrane and from membrane to reservoir. Okay, from reservoir to membrane and from membrane to this layer. Okay, So now, but DM and DA are diffusion coefficient, okay, which of membrane and the this adhesive layer, okay. HM and HA are the thickness of rate controlling membrane and adhesive layer. So you must mention this definition when you are discussing the systems. So always remember this equation. Now, if you elaborate this, put the values of PM and PA there. So the equation will be like this: dc by dt is equal to KMR into KM into DM into DA upon KMR into DMHA plus KM DA HM into CR. So we have discussed all the what are the variables here. So you must, whenever you are mentioning the equation in from exam point of view, it is utmost essential that you put where KMR and KM is this, DM and DA is this, HM and HA is this. You should be clear cut mentioning of these things should be ensured by you. Now moving to the next system, what is this adhesive dispersion type system. As the name suggests, the drug reservoir is formulated by directly dispersing the drug in an adhesive polymer which is adhesive in nature, and then spreading the medicament or this medicated adhesive by hot melt onto a flat sheet of drug impermeable metallic plastic backing to form a thin reservoir layer. As you can see here in the upper part, we can see here, okay. So on the top of the drug reservoir, adhesive polymer of specific permeability and constant thickness are applied. Okay, so you can see here in the that backing layer is here, then drug reservoir, rate controlling membrane, contact adhesive, protective peel strip, and this constituting this is the complete adhesive dispersion type system, which can be applied easily on the skin. Examples include again ISDN, isosorbide dinitrate releasing transdermal therapeutic system for OD doses for angina pectoris. In the adhesive dispersion type system, let us discuss the rate of drug release again. dq by dt is equal to kr into da into cr upon ha, okay, where kr is partition coefficient for the interfacial partitioning of drug from reservoir to adhesive layer, okay, from reservoir to adhesive layer. Da is the diffusion coefficient in adhesive layer, while Ha is the thickness of adhesive layer, while the Cr is the drug concentration in reservoir. You must mention all the variables. Now moving to the third one, matrix diffusion control systems. These systems can be made by step 1, if you say, by homogeneously dispersing the drug particle with a liquid polymer followed by cross-linking of the polymer, or by dissolving the drug and polymer in a common solvent followed by solvent evaporation in a mold at an elevated temperature or in a vacuum. Okay, this is the general diagram of matrix diffusion control system. Please remember this. Next step is what you will do, that medicated polymer but which you have prepared is molded into a medicated disc with a defined area and thickness. The drug reservoir containing the polymer disc is pasted on. It is pasted onto a occlusive base plate in a compartment fabricated from a drug impermeable plastic backing. Now the adhesive polymer is then spread along the circumference to form a strip of adhesive rim around the medicated disc. So this makes your matrix diffusion control system. You can see here, these are the peripheral the adhesive layer is there, and this is the matrix of the drug. Okay, medicated polymeric matrix is here. Okay, this is the matrix here. As you can see, drug is there. So again, the dq by dt can be given by square root of L into Cp into dp divided by 2t, where L is initial drug loading dose dispersed in the polymer matrix. Cp and dp are the solubility and diffusibility of the drug in the polymer respectively. Okay. So in the reservoir and the polymer respectively. Now Example include nitroglycerin releasing transdermal system, nitrodur and nitrodur second at daily doses of 0.5 gram per centimeter square for therapy for angina pectoris. This can be prepared. And now we are moving to the next one. Micro reservoir type or micro sealed dissolution control system. As the name suggests, they are having the micro reservoir. Basically, these are combination of reservoir type system, matrix type system. So what is happening? We are preparing a reservoir and putting them into the matrix system. Okay. Step one is drug reservoir. You will prepare by suspending the drug in an aqueous solution of soluble liquid polymer, water soluble liquid polymer, and then in the step 2, dispersing the drug substitution homogeneously in a lipophilic polymer such as silicon elastomer with high speed shear force. Then in step 3, microscopic spherical reservoir with entrapped drug is obtained, okay, and it is cross-linked by addition of polymeric cross-linking agent, and thereby the matrix is formed. So in step 4, a backing is attached and the peripheral adhesive layer is attached. So small micro reservoir there which are entrapped in the polymeric matrix, and this forms the micro reservoir type micro dissolution controlled systems. Examples include nitroglycerin releasing transdermal system, nitroglycerin like and nitro disc is there for once daily therapy. So different types of systems are prepared in this, and drugs are here, backing drug reservoir, you can see here. The microseal systems are prepared. In poroplastic type system, this it is made by utilizing the concept of water coagulation of cellulose triacetate solution in organic acids at low temperature. The coagulation is performed under controlled condition. The water may be exchanged subsequently for another vehicle by a diffusional exchange process, and hence it is also known as solid composed mostly of liquid. Now let us discuss the evaluation of transdermal drug delivery systems. Evaluation of adhesive. First, it is classified. You can classify it in these certain classes, certain subtypes. Like first, you will evaluate the adhesive. Second, the drug release will be there. Third will be effect of skin uptake and metabolism, in vivo studies, cutaneous toxicological evaluation, and some other tests are there. Miscellaneous tests are there. So we will be taking up one by one. In evaluation of adhesive, peel adhesion properties is there. It is the peel adhesion properties. Okay. Then tag properties, shear strength properties. In vitro release studies, paddle over days, permeability or diffusion studies, and other. So you just remember this chart whenever you are answering the question. And because in transdermal, percutaneous absorption is the question number 1, question number 2, advantage disadvantages, question number 3, various types of systems. These 4 systems we have discussed, and then the evaluation. These are the 4 major questions which are very important to address when you are covering this subject. Now first test in adhesive test is peel adhesion properties. What you are going to do, it is the force required. It is the force required to remove an adhesive containing from a test substrate. What you will do, that actually this property is affected by molecular weight of the drug, molecular weight of the adhesive polymer, actually the type and amount of additive and polymer composition. It is tested by measuring the force required to pull a single coated tape applied to a substrate at an angle of 180 degree. If no residue is found, then the adhesive failure is there, signifying a defect of cohesiveness. So you can see here in diagram that this tape is affixed here, and we are peeling it at 180 degree. Okay, so the force required is noted here, or you can say you will see that that whether the remnants are there or not. Okay. Tag properties. The ability of polymer to adhere to a substrate with little contact pressure is called tag. It is dependent on the molecular weight and composition of the polymer, as well as the use of tackifying resin in the polymer. Okay. It may be done in various ways. There are 3 major tests: RBTT, rolling ball tag test, QST or PTT, quick stick test or peel tag test, and probe tag test. Okay. So these are some of the various strategies of, adopted by various industries, which you can see in these diagrams. However, we'll address one by one. First is rolling ball tag test. In the rolling ball tag test, what you are going to do? As the name suggests, it involves the measurement of a distance that a stainless steel ball travels along with a upward facing adhesive. And what you are doing, as you can see here, this is a ball of a standard size and an inclination of standard inclination of 22.5 degree slope is there. What you'll do, that adhesive film you will prepare, adhesive film you will put here, okay, and the stainless steel ball is moved from this inclined plane. So how far it is going, it is measured, because it should go less farther if the adhesive is good, okay, because adhesive will check its movement. So less tacky the adhesive, the farther the ball will travel, okay. So this is the actual picture you are seeing here, okay. Now tack properties in the second test, quick stick test or peel tack test. The peeling force required to break the bond between an adhesive and substrate at 90 degree at a speed of 12 inch per minute. So we are, as you can see here, they at 90 degree, this film is being peeled off at a speed of 12 inch per minute. So the force recorded as the tack value and is expressed in ounce or grams per inch width, with higher values indicating increasing tack. Okay, increased tack is higher values. It is indicated by the higher values of this force. Now moving to the next one, probe tack test. As the name suggests, there is a probe there. The force required to pull a probe away from an adhesive at a fixed rate is recorded as tack. It is expressed in grams. In grams, what you do, there is a probe is here, and the probe, this is the adhesive film. So the force required to pull the probe away is recorded, and it is called, that's why it is called probe tack test. Now moving to the shear strength properties, what you are doing, it is affected, basically the shear strength properties are affected by molecular weight as well as the type and amount of tackified that tackifier added. It is determined by measuring the time it takes to pull an adhesive coated tape of stainless steel plate when a specified weight is hung from the tape, which pulls the tape in a direction parallel to the plate. Okay, as you can see, what you are doing, a adhesive coated is there, and then you are a probe this stainless steel plate is hanged, and weight have been fixed here. So you will note down the time it takes to pull, how much time it can withstand this thing. So shear strength properties can be determined by this simple test. The design may be different, but the aim is to assess this strength of the film. Now in vitro drug release study, as we have studied in the BCS lecture about the dissolution apparatus, there are the 7 types. There were the 7 types of dissolution apparatus of USP, and type 5 apparatus, if you remember, is paddle over disc. This is used for in vitro drug release study of the transdermal films. Actually, this is nothing but just a jar, standard jar of USB dissolution apparatus. A disc, pattern disc, you can fix so that it remain little bit above from the bottom of this hemispherical jar, and then you can put that you can affix the transdermal patch on the backing side to this affix to this disc, and then the dissolution, the paddle is hung over there, and in routine way the dissolution study is done, and the data is collected. So by this way in vitro drug release can be performed in the simple USB dissolution apparatus. Now it is called type 5. Okay, remember this, paddle over disc, and you can all the measurements are same, just this disc measurements are like this as we have mentioned here. So please do remember the specs of this USB dissolution apparatus type 5, which is meant for in vitro drug release study of the transdermal films or transdermal delivery systems. In vitro drug permission study by diffusion cell. As we have discussed also in the BCS that they are the diffusion cells are small in size. They are not as big as the dissolution apparatus. They have got the two compartment, donor compartment, upper and lower one is receptor compartment. A semi-permeable membrane is affixed. It may be artificial membrane, it may be a natural one, maybe made of human cadaver or skin of the rat or the intestine of the rat. Uh, it is mounted in between the donor and the receptor compartment. Okay, and the media in the receptor compartment is agitated on a magnetic stir, and that media is always in touch with this with the semi-permeable membrane, which is in between, which is tied in between the donor and receptor compartment. So samples are removed at different time interval from the sampling port and replaced with the pre-warmed same amount of receptor media to maintain the condition, to maintain the homogeneous condition, and then we can analyze the samples with respect to the time, the drug release versus time, or drug permeated rather we'll call, versus time can be studied. Now here we are seeing the Kesri chain cell and French diffusion cell. So these are two major vertical diffusion cells, vertical type diffusion cells. So there may be vertical and horizontal also. So in vertical, as you can see, there is a donor compartment. This is a donor compartment. The lower one is the receptor compartment, and that the membrane is there. This membrane it can be affixed. Okay, and this is a sampling port, and the water jacket is around the receptor compartment, and the stirring bar can be added at the bottom of the receptor compartment, and this entire assembly is put on the magnetic stirrer. Okay, in the same way the Kesri chain cell is there. Little bit difference is there until you maintain a hydrodynamic or thermodynamic condition. You can design anything as a diffusion cell. Okay. Now let's move to the horizontal diffusion cell. Horizontal diffusion cell, there are the two major categories of horizontal diffusion cells. Wallechin cell, as you are seeing here, there are the small compartments, horizontal compartment here rather than vertical. Horizontally the membrane is there. Actually the membrane is in between these two donor and receptor compartments, and the flow of the drug is horizontal. Okay, that's why they are called horizontal diffusion cell. Okay. This is the ray diagram here, and this is the actual diagram on the left side. You can see. So by this way, Wallechin cell, and in the similar way the Ganman-Chin cell, GC cell is there, which is larger in size little bit. So you have the three vertical type diffusion cells and two horizontal type diffusion cells. Let's compare their properties. The volume receptor cells in Wallechin cell is 3.5 ml in each half cell. They are called one half cell, the second half cell. So 3.5 ml in each half cell. In Ganman-Chin cell, the volume is little bit more, 140 to 250 ml in each half cell. While in the French diffusion cell, it is just 10 to 12 ml. In KC cell, 12 ml, and Jawar-Lordy JL cell, 1000 ml. Jawar-Lordy is simply dissolution apparatus. In a jar is there, okay, and you can use it as a diffusion cell. Basically, basket is hung. You use a basket type dissolution apparatus as the Jawar-Lordy. So Jawar-Lordy said that the same can be used. The dissolution apparatus same basket type can be used for the as a Jawar-Lordy cell. So effective membrane area is 0.64. It is 0.64 centimeter square, while it is in GC 13.9, little bit more, 1.57 to 4.75 centimeter square in French diffusion cell, 3.14 centimeter square in the case of KC cell, okay, and in Jawar-Lordy is 12.6 centimeter square. In speed, you can say more over 600 rpm in every diffusion cell, except you can say in Ganman-Chin cell, which it can be varied in 60 to 1000 rpm. So this is a comparative chart of the diffusion cells. So you can just draw it and you can present it rather you make all the five the dissolution apparatus. This is a homework for you, that you search the Ganman-Chin cell diagram and draw it. Okay, so by this way you will have all the 5 1 and you can represent it quite effectively when the question is asked from you. In vivo studies, animal models, any animal model can be taken in mouse. It can be done in mouse, rat, guinea pig, rabbit, hairless mouse, hairless cat, hairless dog, cat, or you can say goat, squirrel, monkey, rhesus monkey, chimpanzee. The rhesus monkeys are the most reliable model. Standard radio tracer methodology can also be adopted, and application site is generally the forearm, okay, and the abdomen, which are less hairy sites in the animal body. The compound is applied after light clipper shaving of the site. What you do, you perform the slight shaving you do, or hair removing cream, or by the razor you can remove the hairs, and then you should apply your transdermal film. Okay, and then after a certain period of time you should take the plasma. You should analyze the plasma level by any whatever you are means you are adopting. Human volunteers can also be used, but they are time these methods are time consuming, and very ethical things are related with these options. Biophysical models are also there, which are used many times, in which a hypothetical model can be developed, which is, you can say, ex vivo kind of physical models. They are in between the in vitro and in vivo. Now, moving to the some of the methods which are apart from this, like surface morphology. You perform the SEM of the surface of the transdermal film. This will give a good idea that how and it can be correlated with your release or permission, that it may determine, because the surface may determine, the more the contact point will be there, more it is going to be reacted by the and the diffusion will be more. So what we mean to say that apart from surface morphology, which is done by SEM, thickness can be measured, and the moisture content because the moisture content is also the indication of the stability, because okay, it should be neither too less or not too high. Okay, if it is too less, it will be brittle. It is too high, it will be very plasticity will be higher. Okay, so as far as the plasticizer is concerned, you add the glycerin, propylene glycol, which also act as a penetration enhancer. Okay, folding endurance. Folding endurance, as the name suggests, how much folding they can endure. So what you do, you fold that film from a specific portion. You take a longer film and fold it one side and on the opposite side, and you see how many times it will be it is going to withstand without cracking. uh, so you will just mention the numbers. It is a unitless thing, just the numbers are there, that 13, it may be 135, maybe 370 times you are folded it, and that it can withstand. So it means 370 is the folding endurance of that film. That's a very simple uh, evaluation parameter. Then tensile strength, as we have mentioned, as you shear strength can be measured in the same way, tensile strength can be measured, and the tape can be hang to a tensile strength apparatus, and the weight increase in weight can be increased. The weight required to break that film may be indicative of tensile strength. Other uh, very sensitive evaluation parameters may also be there, but these are the most common evaluation parameters of transdermal drug release system, or specifically the transdermal films. And remember, all these parameters are going to be same for mucoadhesive films, films or mucoadhesive patches, bioadhesive patches. So we are not going to repeat them again in the mucoid when we will be addressing the mucoadhesive drug release systems. Okay, remember that, because if it is a film, film is a film. Okay, all the characterization parameters will be same. However, these mucoadhesive film may have one or more extra characterization parameter which are related to their bioadhesive nature or mucoadhesive nature. Okay. Now, what are the advanced transdermal drug systems? The chemical enhancers are there. We have seen the chemical penetration enhancers. Now, physically, if you want to increase the penetration across the skin, we can give either we can do it either with the help of electric current, small electric current, 10 to 20 millivolt of electric current, that is done by the iontophoresis. Ionized drug are repelled through across the skin which are called iontophoresis. Sonophoresis, the same way, when the sound waves are used for repelling the drug across the skin, it is called sonophoresis. Microneedles, small needles, as you can see here, it are just small needles are here. So the group of needles are there. So when they will be affixed, they will be acting as injections. Okay, these microneedles will deliver small amount of drug directly to the skin and avoiding the first pass metabolism without any pain. It is non-invasive, you can say, because it is, they are not going to prick, just like they are not going to prick like the injections. Okay. So there are some more techniques, but these are the most basic techniques, or you can say most common advanced techniques. So please do study, and if you want to go into the detail, you can refer to the further readings which we are giving here, the further readings and the references here. So do study and do learn these advanced techniques also, apart from the basic what we have taught to you. Now let us summarize what we have learned. In our previous lecture, we discussed about the basic concept of percutaneous absorption of drug across the skin, how the mathematical modeling is done, and what are the advantages, what are the limitations of transdermal drug delivery systems. Now, as far as the preparation method which we discussed in this lecture, the transdermal drug system may be reservoir or the matrix system. They are of four major types: membrane permeation control system, the adhesive dispersion type system, diffusion control system, and micro reservoir system. Okay, so the systems may be designed depending upon your requirement, and depending upon the release requirement. You can select any particular type of system. As far as the characterization of transdermal drug system is concerned, you will go for the adhesive analysis, adhesive evaluation with the set of tests which we have discussed, like rolling back tech test and QST, peel tech test. So by these tests you can go ahead, and then we study the in vitro drug studies with the paddle over disc USP type 5, and the diffusion cells, vertical and horizontal. In among the vertical, Franz and Kestrich; in horizontal, in vertical 3, okay, Franz, Kestrich and Java Lordi; and in horizontal 2, Valiachin and GC cell. So remember the comparative parameters which we have discussed along with their diagram in diffusion cells. Apart from that, in vivo studies can be done, and other than these parameters, thickness, surface morphology, and folding and moisture content can also be measured as a characterization. Please do study the advanced techniques like iontophoresis, sonophoresis, and microneedles, etc. for your knowledge, if you want to go for the further or advanced knowledge about the newer transdermal drug delivery systems. So this was all for the transdermal delivery system. We'll be coming with some new lectures in our new topic, in new lecture in our coming lectures. So stay tuned, happy learning, and prepare for your exams. Okay, thank you for being with us. Happy learning.